All right, you guys, so previously we went through the procedure of how to graph linear inequalities. Now we are going to look at an example problem, okay? So our problem here says graph x minus y is less than 5, okay? So the first thing that we're going to do, we're going to solve for y, okay? Now when we do that, we have negative y is less than negative x plus 5, okay? So we simply move the x to the other side of the equation. Okay. Now, since we need y to be by itself, we're going to have to divide this entire equation by -1. When we do that, remember, anytime that you multiply or divide by a negative number when you're dealing with an inequality, you flip the inequality symbol. So you can see here that we started with a less than symbol. When we divided by -1 to get y by itself, our inequality symbol flipped. So now we have greater than symbol. Okay. Now that y is by itself, okay, we can get our related equation. So remember, your related equation is the exact same thing as your inequality without the inequality symbol, okay? So you can see here that all I've done is replace our inequality symbol with an equal sign. Nothing else changed, okay? Now, since we have this equation, you can graph this line however you want to. So if you're comfortable with using slope-intercept form, you can use that. If you want to find x and y intercepts, you can do that as well. So whatever way you are comfortable with drawing a line, go for it, okay? When I go to draw in my line, I need to keep in mind that I'm going to use a dashed line. And I'm going to use a dashed line because my inequality symbol is greater than. It does not have the line underneath it, which means equal to. So I'm going to use a dashed line. So for me, what I did, I just found the intercepts. Okay. You could also use slope-intercept form since that is the form this line is in. And you can see that your y-intercept would be -5, which I've plotted this point. And our slope would be 1. So you could do rise over run, 1 over 1, 1 over 1, and you can graph it. Because I've done my intercepts, I've just plotted my x and y intercept. Now, when I go to connect these points, remember I'm going to use a dashed line because my inequality symbol was greater than. So you can see now that I have this boundary line, okay? Now, when this boundary line is on my xy plane, you can see that it kind of splits this graph into two pieces. I have this part of the graph that sits above the line, and I have this part here that sits below it, okay? Now I'm going to have to determine which one of these sections I'm going to shade because one of those sections is going to contain my solutions. So in order for me to figure that out, I'm going to choose a test point. Now I can choose whatever test point I want as long as it's not a point that falls on the boundary line. So for me, I typically choose 0, 0, just because it's easy and it's easy to calculate. But if you wanted to try something different, go for it, just as long as it doesn't fall on this line. So since I chose 0, 0, it doesn't fall on my line, so I'm good. I'm going to plug that point in to my inequality. And I'm looking to see if that coordinate makes my inequality true or if it makes it false. So when I plug in 0, 0, 0 for x and 0 for y, I get this, where 0 is greater than -5. So is that true or is that false? Well, that's true. 0 is bigger or greater than -5, okay? So I look where my point is. Because my test point made my inequality true, that means that everybody else on this side of the line is also going to make my inequality true because 0 falls on this side, okay? If this would have made it false, I would have shaded the other region. So you only want to shade what makes your inequality true. So because mine's true, I'm going to shade towards my test point, okay? And you can see this would be my solution, okay? This graph with the boundary line and my shaded region, all of this makes up my solution to this problem, okay? All right, let's try another example. Okay, so this time I have x minus y is greater than or equal to 5. So I'm going to walk myself through those same steps that I did before. So I'm going to solve for y first. So that means I'm going to move x to the other side of the equation. So I'm going to subtract it. And then I need to get just y, not negative y. So I'm going to divide both sides of my equation by -1. And remember, anytime you multiply or divide by a negative number, you're going to flip your inequality symbol, which you can see here. It flipped my greater than or equal to a less than or equal to sign. Okay. All right, now that I have y by itself, I'm going to go ahead and find my related equation. And remember, your related equation is the exact same thing as your inequality without the inequality symbol. So I'm going to replace it with an equal sign. Okay. Now remember, at this point, you can graph your line whichever way you feel most comfortable. So if you want to do slope-intercept form and finding the slope and the y-intercept and plot those, you can. Or if you want to find intercepts. All right, now remember, I have to keep in mind that when I go to draw my line, I'm going to use a solid line this time because my inequality symbol has a line underneath it, which means equal to. Okay, so for me, I just went ahead and found the intercepts, the x and y intercepts. So I plotted my 2 points on my graph, okay, and then I go to connect them, and I use a solid line. And now remember, at this point, I need to figure out, okay, now which region do I shade? So once again, this line has split this plane into 2 parts, above and below. So I need to choose a test point. Remember, you can choose whatever you want as your test point, as long as it doesn't fall along your boundary line. So for me, again, I choose 0, 0. It's my favorite. So it would be here on my graph where my 2 axes meet. And I'm going to plug in my test point into my inequality, okay? When I do that, I end up with 0 is less than or equal to -5. And as I can see, that is false. 0 is not less than -5. So since my test point would be here, it would be above my line, that makes it false. So I don't want this region, because if my test point makes this inequality false, that means everybody else on this side of the line will also make my inequality false. So I'm going to shade the opposite region. Okay, so once again, your solution encompasses this line, your boundary line, as well as this shaded region. Okay, cool. All right, so we can see you can plug in any point you want, right? So I always choose 0, 0 if I can, but remember, you could choose any other coordinate on this graph. The work that you use to prove whether or not your solution is true or false will be the same. So regardless of whatever point you choose, you're going to plug it in your inequality, see if it makes it true or false. Cool. All right. All right, let's look at this example. So it says graph the linear inequality, and this time we have y is greater than 4x plus 4. So we're going to walk ourselves through those same steps. The first thing you're going to do is you're going to look for the boundary line. So in this case, I didn't have to get y by itself or isolated. It was already isolated. So to find the related equation for the boundary line, remember you just replaced the inequality symbol with an equal sign. So that's how I got y equals 4x plus 4. And then I'm going to graph it. Remember, you can graph your line whatever way makes you feel most comfortable. I found my intercepts again. Okay, so when I did that, I got 0, 4, and -1, 0. I plotted those points. Now you can see here on my picture, I used a dashed line. Remember, you use a dashed line because your inequality symbol is a greater than. It doesn't have the line underneath it. Okay, and then for me, I chose a test point. I chose 0, 0 again, no surprise. All right, and I plugged 0, 0 into my inequality to see if it makes it true or false. When I plugged it in, it made my inequality false. So 0, 0, 0, 0 would be here on my graph where my axes cross. And since it made it false, I want to shade the region where my test point did not come from. So that means the other side of my boundary line, okay? Which is why on this one, I shaded to the left, okay? All right, let me do one more with you, okay? Let's look at this one, okay? So same directions. It says to graph the linear inequality. So we have 2x plus y is less than or equal to 3. So we're going to walk ourselves through those same steps. So remember, you're always looking for the boundary line, okay? So in the previous problems, we've always gotten y by itself. It will work even if you don't isolate y in your inequality before you begin. You can simply just replace the inequality symbol. So I wanted to show you that as well. So you could save yourself some time and some work if you don't want to isolate y first. Just replace the inequality symbol, okay? And then you need to graph this boundary line, okay? Remember, you can graph this line however you feel most comfortable. For me, again, I found the x and y intercepts. I just like to find that. All right, so my x and y intercepts turned out to be 0, 3, and 3/2, 0, which I've plotted them. I used a solid line in this example because my inequality symbol is less than or equal to. Okay, so I'm going to use a solid line. And then I chose a test point again. So I chose 0, 0, which would be here where my two axes cross. And remember, with your test point, you plug that into your inequality to see if it makes your inequality true or false. So when I go to plug in 0, 0 into this inequality, okay, I get 0 is less than or equal to 3. And that is true. 0 is smaller than 3. So I shade towards the point. So remember, I chose the origin, and the origin turned out to be like on the left side of this line if you want to look at it, and it made it true. So that's why my left side is shaded. Okay, cool.